Hi guys, my name's Raz and today we'll be looking at implicit differentiation. So firstly, what is an implicit function? Well, a function is described as being implicit if it's written in terms of x and y. So x squared plus 3x plus y squared equals 29 is implicit because you can see at the bit that I've highlighted, x and y are written together. They're not separated. So an explicit function is the one we've got below where we have y equals x cubed plus 4x plus 1, or something like y equals x squared plus 3x, or y equals x plus 4. Whenever it's y equals and then something in terms of x, that would be explicitly stated in terms of x. And the example at the top is mixed up, hence it's implicitly defined. So it's the differentiation of this type of function that we'll be looking at. So there is a little trick, which is whenever we differentiate a function that has a y in it, we simply stick a dy by dx next to the answer. So y squared, if you use the rules of differentiation where xn goes to n xn minus 1, we would get 2 y to the power of 1. Because it's a y and not an x, we'll times the answer by dy by dx. So pause the video and give these a go. Welcome back. So y would differentiate to 1, so the answer would be 1 times dy by dx. Y to the 4 differentiates to 4y cubed, so the answer would be 4y cubed dy by dx. And the last one would be 3y plus 4 to the power of 2 times by 1. So it would be 3y plus 4 squared times by dy by dx. And that's it. That's all we do when we differentiate implicitly. So in this instance, we have a product, so we will need to use the product rule. So I have a u and a v. So the product rule is uv dash plus bu dash. So u times the derivative of v plus v times the derivative of u. So we will have x to the power of 6 times 6y to the power of 5 dy by dx plus y to the power of 6 times 6x to the power of 5. So I can neaten that up and factorize potentially. So I have 6x to the 6, y to the 5 dy by dx plus 6x to the 5, y to the 6, common factor of 6, x to the 5, y to the 5, bracket x dy by dx plus y. Simples. So that'd be the answer there. And this one, we have a u and a v, so uv dash plus v u dash. So x times 4y cubed dy by dx plus 1 times y to the power 4. So the answer will be 4xy cubed dy by dx plus y to the power 4, which we can factor out a y cubed there. So we've got 4x dy by dx plus y. So that is how we would differentiate. Now I'm going to do one more example. And in this question, we asked to find the equation of the tangent and the normal. Let me just blank out the normal part. There you go. So let's find the equation of the tangent to the curve. So first we need to differentiate. So if we differentiate, we have x squared y plus y equals 25. So we use the product rule for this bit. So we'll have x squared times dy by dx plus y times 2x plus dy by dx equals 0. So we can't forget to differentiate the right-hand side of the equation. So now I need to group my terms. I'm going to rewrite what we have. So have x squared times dy by dx plus 2xy plus dy by dx equals 0. So this bit will factorise. And this bit here can go to the other side. So I'll have an equals negative 2x1 on the right-hand side. And I'll have a dy by dx multiplied by x squared plus 1 on the left-hand side. So now I can make dy by dx the subject of the equation. So there's the gradient function. We've been given the coordinate 2, 5. So if we let x equal 2 when y equals 5, we will have the gradient equal to minus 2 times 2 times 5 all over 2 squared plus 1. So the gradient of the tangent will be minus 20 over 5. Yeah, which will be minus, I'll write it down, which will be minus 4. So that leaves it quite straightforward what we need to do now. So we know y equals mx plus c. Therefore, let me use actually. So y equals mx plus c. Yeah. And we have m is minus 4, x is 2, y is 5. So 5 equals negative 8 plus c, c equals 13. Therefore, y equals minus 4x plus 13. So that's how we would use implicit differentiation to find the equation of a tangent. Yeah, that's implicit differentiation. I hope you enjoyed the video. See you soon.